Welcome, my friends, to exercise number 3, complexity. We are asked to find the time complexity of this program. So, I want from you to pause the video, get your paper and pen, and write down this and try to find the complexity of these exercises. Guys, it's very important to work with your own, to solve, to try. But if you are just listening, you will not get a master. You will not be a master, and you will not understand every concept. Please try to solve these exercises because they are very important, and the trying you are making is very important. So after you're thinking and trying to solve them, I hope you find the complexity, time complexity correct. We will start. So if we took int n equal to 1000, so this 1000 is a constant, and int n we are just declaring a constant here. So it is O of 1. If we go to the next line, we are just printing, hey, your input is, and we just need to print the n. Okay, so here in this line, just printing will result in O of 1 only. System.out.print, I'm doing more stuff with plus, and we are again making the same concept by printing n, which is O of 1. So printing or initializing and declaring variables are O of 1. System.out.print and more, printing n also, and printing this message will result in O of 1. So 1, 2, 3, and 4. O of 4, and which is resulting in O of 1. So this time complexity for this algorithm is just. Hello, my friends, and welcome to exercise number 4, complexity. Find the time complexity of this method called hello. It's void, it's not returning anything, and took int array as parameter, and do some stuff. Pause the video, think about it, write down in your paper, and let's find out in the next 5 seconds. Well, my friends, again, I hope you try it, because writing down and trying to solve exercises is very important. We see here that int sum equal to 0. We start by this. We are just declaring a variable. So O of 1. Int product also will result in O of 1. Okay? Now, we have done this and done this. We entered the loop. So, for int I equal to 0, I less than array dot length, I plus plus, and do the stuff. This stuff is equal to O of 1. But when founding an array, it is O of n and O of array length. O of array length. Okay? So it's very important to understand that when you have an array, we are searching and doing this stuff, which is a constant. We're making just an addition operation. So this addition operation would be repeated from 0 to array length. Example, if the array length is 1 million, it will do this stuff 1 million times. And this, if the array length is 1000 would do this for 1000 times. So depends on the array length. This will result in O of n. Again, there is another loop making I from 0 array dot length and make a product. So this product is O of 1, but O of 1. But this loop will result in O of n because we are making, consider array.length is an n variable, okay? This is the notation, and this what we mean by n, okay? Array.length is n, so we are making the product here, a product operation from 0 to array length. Again, if we have array length is 1 million, it will do the sum operation 1 million times and the product operation 1 million times. So these two loops, these two operations will depend on the length of the array. So O of n will represent its state. Now, system.out.print ln, we have seen that when printing anything, and these are constants, and some of them are variable defined, so O of 1. Look at this of this method. We have O of 1, O of 1, ON, ON, and O1. What are the highest order of this equation? If we make summation, 1 plus 1 plus n plus n plus 1, we have n to n plus 3. We remove the we have two terms. We took the highest term and we remove the constant from this term. It will result in O of n. So in this case, we are solving every exercise and understanding the time complexity for every question. Always, when you have an array, please pay attention for the initial value and the limiting value or the stop condition. Okay? And the way they increment, because in the next videos and the next exercises, we are gonna learn about a new form and going in deep by making calculations and understanding how the array behavior and how these conditions, the initial condition, the stop condition, and the increment condition would works to and affects the time complexity. So this example, this array, this method and this algorithm will behave in time complexity O of n, depending on the array length, which is. Hello, my friends, and welcome to exercise number 5. In this exercise, we are asked to find the time complexity of this algorithm. So this algorithm contains a for loop and a system.out.print message. Please pause the video and think about this question. Solving more exercises by your own is the key of the success and mastering the data structures and algorithms. So through the course, we are going to solve many exercises. I hope you pause the video on every exercise and write down your solution on the paper. Now, back to our exercise number 5. The time complexity of this algorithm. We start by the simple one. There is a loop here and a printing message. We said that the printing message is O of 1 and it is constant. Okay? It's very simple. Now, look at the loop. we have this section, the initial condition, the stopping condition, and the increment condition. Okay, guys? We are going to understand how the loop behaves in order to get the correct time complexity. So, this loop starts from I equal to 1. Okay? I equal to 1. And I less than n. I will consider for demonstration n equal to 8. Okay? And I every time is I times 2. Now, let's start. Think about this loop. We are going to make an iteration table that we have seen before. So, I is equal to 1 at the first stage. Okay? N is equal to 8. And what the input here? System.out.print. Hey, I am busy looking at I value, which is 1. Please concentrate with me, guys. This is the first time, this is the first iteration. Okay? Now, this is executed. Going up, I is increased by 2. So 1 times 2 is equal to 2. So this is 2. Okay? Now, I equal to 2. 2 less than 8. Yes. So go and print again this message, and I equal to 2. Now, going up. Again, I equal I new is equal to the old new as the old I times 2. So new value of I is equal to 2 times 2. 2 times 2 is equal to 4. N is equal to 8. 4 less than 8? Yes. So go and execute what inside the loop. So I is equal to 4. Now, going up, again, I is equal I, the old I, which is 4, times 2 is equal to 8. 8 less than 8? No. So go and stop. We need I less than or equal 8 to continue. So this will not be executed anymore. Okay? So what this means to us as executing 3 messages instead of 8. If we don't have I equal I times 2, if we think about I plus plus, then we need to have 8 printings. 8 printings, okay? But here in I equal the old I times 2, we are jumping. I think about it as 8. So we are, every time we are jumping to 1, 2, 3, 4, 5, 6, 7, and 8. The first time was 1, 2, 4, and 8. And we cannot reach 8. So 1, 2, 4. It is executed 3 times. This number is very important. 3 times is very important. In math, we have n equal to 8. Log 8 is equal to 3. So we have executed, we have entered n equal to 8, and we executed the message system.out.print 3 times. This means the complexity is executing 3 times. We are executing 3 times this algorithm. So system.out.print is printing this 3 times instead of 8. So log 8 is equal to 3. This means the complexity is equal to O log n. Okay? So log 8 equal to 3, which means this is the time complexity